Hi, folks. I'm over here. There we go. Sorry, I wasn't lined up the way I usually am. In this video, I'm going to show two of the Newton's first law demonstrations that we did in class. Unfortunately, I don't have a pie pan or a able to be used toilet paper tube roll. So if we weren't in class to do the demonstrations, you'll be writing and reflecting on only two of the Newton's first law demonstrations that you can easily replicate in your house. If a toilet paper tube roll, actually I might record it tomorrow in class and then we'll put it up on YouTube. So this video will have two of the three. The third one will be the egg drop tower that I'll make another video for. But in this video, we're going to do two of the demonstrations. For those of us that weren't able to be in class, you can use this video to still answer the prompts about Newton's first law in terms of describing what you're going to witness in these two videos using the law of inertia, Newton's first law. The first one that we're going to do is the wear your seatbelts demonstration. So I have here, down here in the big video now, here I am over here. Down here on the floor, I have this red remote control car. And on top of the remote control car is an action figure. Here we've got Michelangelo. In class, we used a G.I. Joe action figure, but here we've got Michelangelo. We're going to set him on top of the car, just like that. And now we're going to run the car into the wall right over there. And our job is to describe as completely as possible using Newton's first law what happens. We've got a little peeker sneaking behind me. All right, so let's run him into the wall. 3, 2, 1. Perfect. So thinking very carefully about what happened to the figure after the car struck the wall. We can describe that using Newton's first law. I'm going to pause the video and rearrange the cameras for a little bit to look at the second demonstration. Okay, we're back here. Now I have here this piece of just plain computer paper, and we're going to do the tablecloth trick, what's called the tablecloth trick. Now in class and in the description of this, we talk about using these little blocks. So these cubic samples, we use the aluminum and the copper when we did our density activities. And in class we had a little wooden block, either maple or pine, and then one of the heavy blocks. Again, it was either the iron or the copper, depending on which ones I put out. But I'm going to show you a way that you can do this little mini version of the tablecloth trick with another easy, most students, for whatever reason, don't have a density set of 10 specimens in their home. But here's what you probably do have. I have this plastic cup, this little yellow plastic, camera 1, camera 2, this little yellow plastic cup. And we're going to look at what it looks like to pull the tablecloth out from underneath this cup with it empty first. So this is a pretty lightweight cup. This would be even more dramatic if we had a thin plastic like a red Solo cup or a clear plastic cup. We don't have any of those in our house. I guess that's an environmental brag. We don't have any of those disposable plastic cups or little paper cups, but we do have this one. So let's see what this looks like to do the tablecloth trick. Well, I don't like my camera angle, so let's see if I'm over here. Let me adjust this just a little bit. Okay, sorry about that pause. I had to rearrange a little bit. So we're going to do the tablecloth trick. We're going to just pull the tablecloth out quickly from underneath this. Perfect. So it worked, right? But this cup wobbled a little bit, right? Did we see that? Whoops. Let me get my paper good. 3, 2, 1. Yeah, it moved a little bit. Well, that one was pretty good. But I still have my cup a little bit there wobbling. If I go a little slower, I can accentuate that cup moves just a little bit. Now, compare that to what's going to happen if I add some water to the cup. La, 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 la. Adding water. Now, I do have to be careful to make sure that my table is nice and dry. We don't want my paper towel, or not my paper towel, my piece of paper to get wet. I probably wish I had a paper towel here. We want a nice dry surface for this. So here we have a cup that's now full of water. it is going to be a lot easier to get that cup. It's a little more stressful also. I don't want the water to go in my lap. So I've got to be nice and quick with the paper. That cup stays still a lot more noticeably than it did. That wobble was a lot more prevalent when the cup was empty. That is something that we can explain, the difference between those two scenarios, one with the full cup and one with the empty cup that wobbled a little bit, using Newton's first law. I'll post an additional video that we'll make in class tomorrow, doing the egg tower, because all of my egg tower supplies are at school. So there'll be a third video. Again, folks that weren't able to be in class last week or this week can still use these videos to answer the prompts about Newton's first law. Great work, everyone.